All right, functions. Yesterday we did these problems in class. We found f of g of 3, which meant we found that g of 3 was equal to 2/3, and then we took that new input, that output, and plugged it into my f function, and we ended up with 3 times 2/3 plus 2, which is equal to 4, because that is 2 plus 2 is 4. Then we did it again with g of f of 3, and we ended up with a 2/11. Okay, so we did that in class. Now we're going to take that and we're going to transfer that knowledge by putting the whole function inside of a function. So we are going to find g of f of x. Again, the first thing we want to find is g of x. Hold on, let me go back and hit pause. Okay, so the first thing we're going to do is we're going to find what f of x equals when it's next to this, because it's closest to the input, we're going to find that, and f of x equals x squared plus 3. Then we're going to take all of that, so we're going to do exactly what we did yesterday, except for we're not finding a number, we're doing the function. We're going to take g, and we're going to take that x squared plus 3, we're going to plug it into g. So everywhere, that's my new input. Now this isn't any different than what we've done before. We're just doing it one at a time. So now we're going to put that in g, and g is 1 minus 4x. So everywhere I see an x, I replace it with x squared plus 3. And then I just need to do this. So negative 4 times x squared is negative 4x squared. Negative 4 times 3 is a minus 12. Combine like terms. And I end up with negative 4x squared minus 11. Okay, this is a quadratic. I know that because the degree is 2, and since it's a quadratic, my domain is going to be negative infinity to infinity. I don't know why I wrote this sideways, but I did. All right, we're going to do the same thing here. Here, we're going to find g of x first. I kind of like the way that this looks. It's a little bit easier to read. This reminds me that I'm going to put that whole g of x inside of f. This one I've got to know that. This one I can kind of see it. So I'm going to find g of x, which is g of x, here we go, equals 1 minus 4x, and I'm going to take all of that and plug that in my f. So I'm going to have 1 minus 4x equals, I have x squared, so 1 minus 4x squared plus 3. Again, when we have a binomial like this, this really means that we need to put it in a box. I'll just do it right here. So I have minus 4x1, 1 minus 4x. So 1 times negative 4x is negative 4x. Negative 4x times negative 4x is a positive 16x squared. 1 times 1 is 1, and 1 times negative 4x is negative 4x. Combine my like terms, and I end up with, I get 16x squared minus 8x plus 1. Notice that I didn't put them in the same order, but I still get, I bet you I got what you got. Plus 3, combine like terms, and I get 16x squared minus 8x plus 4. Again, my highest exponent is a 2. It's a quadratic, meaning that my domain is going to be negative infinity to infinity. If you weren't sure looking at that, then I would suggest that you put that in your calculator, graph it, and have a look at it. All right. If you have any questions on this, please ask. You should be able to work on your homework in pearson.com/mylab. It is Unit 2 Functions Part 3. Okay, so let's do this next 2. Oh. Okay, so we're going to do the same thing. So I want you to hit pause, and I want you to try these two on your own. I had everyone in class do this on their own. So if we were going to do this, we would find g of x first, and that is equal to 4x. Oof. So we've got g of x is equal to 4x. I rewrote it so you could read it. We're going to take that new input, or that output, and make that our new input. So I'm going to plug it into f. So 4x goes in here. That's what g of x equals. And everywhere I see an x, I'm going to replace it with that 4x plus 2. So then I'm going to figure this out. Now remember, when we look at something like this, we have to do PEMDAS, order of operations. Order of operations tell me that I do the cube first before I multiply everything by -1. So I'm going to get -1 times 4 cubed is 64, x cubed is x cubed, plus 2. Multiply that by the -1, and get -64x cubed plus 2. This is a cubic, so the graph, the parent graph, is going to be something that looks like this. So then that means my domain is going to be -infinity to infinity. Okay? We're going to do the same thing over here. So hopefully you did hit pause, and hopefully you are doing this on your own. We have to find f of x. My f of x is equal to -x cubed plus 2. I'm going to take all of that, and I'm going to plug it into g. Oops, forgot the negative. Okay, everywhere I see an x and g, I replace it with my new input. So I have 4 times x -x cubed plus 2. And that's it. So then I just distribute. So 4 times -x cubed is -4x cubed. 4 times 2 is 8. All my like terms are, there aren't any, so I can't combine any like terms. So that's going to be my final answer. And my domain for that, again, it's a cubic, so it's going to look like this. And it is going to be -infinity to infinity. That's an infinity. There we go. Infinity. All right. If you have any questions, please let me know. Otherwise, I'd like you to start working on part 3. We will have a work day tomorrow in class so that you can ask as many questions as you need to. Otherwise, I hope you have a great night, and I'm glad you came and got notes.